Algebra. We are moving along in Unit 2, talking about rule number 2, CO11, how to simplify expressions with exponents when dividing by the same base. So in CO10, this word dividing was multiplying, right? And we looked at expanded form. We talked about the rule. You have to practice with it. Same kind of setup here. We're going to use expanded form to kind of look at what it means to divide by the same base and then how to simplify. And if you look at the questions that are on the examples here and your homework, what do all of them have in common? Except for that extra 12th there. Every other one, what do they all have in common? They're all fractions, right? Which the fraction being the operation of division. This is because eventually I'm going to give you an expression and you're going to have to decide what rule do I use here. It's going to be open-ended. And kind of your hints, if you see a fraction, which is division, you know that you are dividing by the same base. Okay? So here's how it works. The first example here, 3 to the 5th divided by 3 squared. First of all, is that 3 a coefficient or a base?
Base.
Is a base. Okay? There are 5 3's all being multiplied together there. So in expanded form, the numerator of this fraction is going to be 3 times 3 times 3 times 3 times 3. Right? And then the denominator, 3 squared, is just going to be 3 times 3. And notice where I placed those 3's in the denominator. That was intentional. And you're going to see why in just a little bit. Because our job now is to simplify this. Okay? And think back to when you first learned about division, 4th grade, 5th grade, whatever it was. There's a rule that you learned regarding something divided by itself. Kira.
Doesn't it always equal 1?
Yes. Anything divided by itself equals 1. So I placed those 3's directly underneath those 2 3's in the numerator because we can cancel them out. 3 divided by 3 equals 1. That pair of 3's is gone. 3 divided by 3 equals 1. That pair of 3's is gone. And now we've canceled out everything that we can because there's nothing left in the denominator to cancel out. What do we have left? Well, what's in our numerator there? How would you write 3 times 3 times 3? Using a power. We're not evaluating here. We're just simplifying. Yeah. 3 cubed. Ooh. Grab the wrong marker. Okay. 3 cubed. Okay. And then what's left in our denominator? Nothing. Everything canceled out. So if you wanted to put a 3 cubed over 1, you could. And I should actually probably write this over more to the right so you don't get. Okay. But we have 3 cubed left in the numerator, nothing left in the denominator. If you want to put over 1, you can. But this would be our simplified answer. Right? 3 cubed over 1. And the reason why it's 3 cubed is because that's how many 3's we've got left in the numerator. Yeah.
Can you just write 3 cubed or do you have to have?
Yes. If you just want 3 cubed, that's perfectly fine. You don't have to put over 1, but you can if you want. All right? Second example. How many 6's do we have up there?
6.
How many 6's do we have in the numerator, Anthony? Just 1. Okay? We have 6 because it's a coefficient. And then our base of x, we have 4 of them. And then 2 z's. Right? 6 times x times x times x times x times z times z. And then in our denominator, we have 1, 3. Again, that's a coefficient. Times x times x. And I'm going to put my z's more over here. I'm going to kind of skip a spot and put z times z times z. And again, that's intentional. Okay? Still says the same thing. In my denominator, I have 1, 3, 2 x's, and 3 z's. But I placed them where I did intentionally. Because what can I do with each pair of x's? What is x divided by x? 1. Anything divided by itself equals 1. So x divided by x, I can cancel it out. It's gone. The second pair, x divided by x, cancels out. Gone. Can I cancel out this x and z here?
No.
No, because they're different bases, right? I don't know what x is. I don't know what z is, but I know they're not the same thing. therefore they can't be canceled out. However, this pair of z's canceled out, and this pair of z's canceled out. So I do know they are the same thing. Right? How about my 6 and 3? What can I do with my 6 and 3? They're coefficients. They're not powers. They're not bases. What do you think, Nolan?
Divide them.
Divide them. I'll give you a button for that. Okay? We treat it like a fraction because it is a fraction, right? 6 divided by 3. What is 6 divided by 3 simplified to be? 2 over 1. We divide 6 by 3, divide 3 by 3, and we're left with 2 over 1. Right? So ultimately, what I'm left with here, in my numerator, I've got a 2, and then an x and an x. So 2x squared. And what's left in my denominator? Nothing. Z. Okay? Everything else canceled out. And so my simplified answer is 2x squared over z. There's some former students hanging out in the hallway. I'm going to go say hi to them quickly. So do the third one. Write it out in expanded form. And then we'll simplify when I return. We're still recording.
Might as well sharpen out a pencil.
No. Wait. I know.
It's just there. I get mad at that.
Yeah, that's right. I got the same thing. Yeah.
Well, are you watching the video?
9 is 3 times 3.
Yeah.
It's 3 times 4.
Okay, so what you should have, that 9 is a coefficient, right? I was gone for like 2 minutes. You can... 1 9 times m times m times m times m, right? 9 coefficient base of m, there are 4 of them there. And then in our denominator, we have that 112 and 1n. Okay? What can I cancel out? What can I simplify? What am I able to do here? I can cancel out the m's, one pair of m's, right? Because anything divided by itself equals 1. What else? What else?
You got to divide the 9 and the 2.
I can simplify my coefficients, right? Because it is a fraction. What does the fraction 9/12 simplify to be? Anthony, 3/4. Divide 9 by 3, divide 12 by 3, I get a 3 and I get a 4. Right? So what's left? What's left in my numerator? How do you write 3 times m times m times m in standard form? 3m cubed. And what's left in my denominator?
4.
Just the 4, right? The m canceled out, the 12 reduced to be a 4, and so 3m cubed over 4 is my final answer. Okay? Now, the biggest question that folks have with this is how do I know where to put my parts? How do I know where to put my leftover bases, my coefficients, things like that? Well, expanded form can help with that because we can see, like in the second one here, why do my 2 x's stay on top? Because that's where they are, right? They started up on the top. I can see that's where my 2 are left. So that's where they will go in my final answer. Why is my z on the bottom? Well, because I still have a z down there, right? The 2 in the numerator cancel out. And so the z that's left being in the denominator, that's where that z is going to go. Okay. Why are my m's in the numerator in the third one? Well, because that's where they are. One of them canceled out, but the rest of them being at the top, they're going to stay at the top. Okay. Questions on this? So just like in CO10, we're going to go down, skip this part. We'll cover the rule on Monday. We're going to come down here, and we're going to write each expression in expanded form, and then simplify it to be one term. So exactly like we did up in the 3 examples. Okay? 9 to the 6th over 9 to the 4th. Is that 9 a coefficient or a base? Peyton, is that a coefficient or a base, that 9?
Coefficient. Base.
Hold on, I'm looking for, there it is. That's what I meant to get. Yeah, okay. It is a base, right? It's attached to the power. And so in expanded form, 9 to the 6th, 9 times 9 times 9 times 9 times 9 times 9, right? And then in my denominator, 9 to the 4th, 9 times 9 times 9 times 9. Okay? And again, my placement of all those numbers is very intentional. It's going to make it very easy, very organized to do what comes next, which is what?
Divided.
Well, yes.
Oh, no, the crossing.
The canceling out,
Yeah.
right? 9 over 9, these 2 9s cancel out, cancel out, cancel out, cancel out. What's my simplified term? Landon,
9 squared.
9 squared. Is that 9 squared in the numerator or the denominator? The numerator. 9 squared. If I want to put over 1, I can, or I don't need it. Okay? That's what's left. If everything cancels out, what's left is a 1, not a 0, right? A 1. Pick one more on this page to do together. I have an inkling which one you're going to pick. Landon?
The 8x.
The bottom middle. Sometimes students are so predictable. That's okay. All right. 8x to the 4th y cubed. I knew that because that's what the last class picked also. Right? And the classes last year and the year before that. So our numerator, 8x to the 4th y cubed, that 8 being a coefficient, is one of them. And then x, 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 y, y, y. 8x to the 4th y cubed. And then in my denominator, I've got a coefficient of 4. This time I've got 5 x's and 5 y's. Whew. I extend that a little bit. Okay? Someone we haven't heard from yet today. What can I do here? Heard from you, Tristan. Thank you. Have I heard from you before, Ellen?
I don't think so. Actually, don't
Maybe.
think so. I don't
Heard from you.
I mean, I've said some stuff in my head. I don't think I actually said it.
Nothing allowed?
Can I try?
Sure.
Okay. So you gotta cross the x, those 4 x's that all match, and then the 2, and then those y's. No.
Yes.
Like you can do that.
Sure. It doesn't matter which y's
Oh, yeah.
cancel out, right? You're still going to be, all 3 of them cancel out up top, leaving you with 2. So it doesn't matter which pairs of y's, just all 3 of them have something to match up with in the denominator.
And then you divide 8 and 4.
Right,
And
and then we can
simplify, and then you get 4 over 2.
Wow, look at you go. Yeah, the fraction 8/4. When you simplify that, you don't get 4. Well, you get 4 over 2, but then that can be reduced further to be 2 over 1, right? 8/4 reduced to be 2 over 1. And then ultimately, what's left? What's left in our numerator? Looks pretty bare, but what's up there?
1 x and 2 y's.
In our numerator,
Oh, nothing's at the numerator, just the 2.
just the 2,
Yeah.
which is something, right? So we can't ignore it, okay? Everything else cancels out except for that 2. And what's left in the denominator? Landon, you had your hand up earlier. Do you want to take this one? Ford MCU.
Oh,
JK,
what?
JK, JK.
What?
That was JK. Call it town.
X
Oh my god.
Remember,
Y
you're
squared.
quiet forever. Talk about this. Unless you see a fire, that's the only time. Otherwise, okay.
X Y squared.
Yes, 1x and then y times y. And how do you know that that's in the denominator? Because that's where they're left. We can see it. Okay, we have 1x left in the denominator, 2 y's left in the denominator. Okay, the rest of this front page, don't do the back. I don't expect you to start writing this in expanded form, n to the 100th. No, okay? Only finish this front page here.
No, I think we need a little bit more on it.
I did?
Yeah, that's sharp. Yeah, that was good.
Is it about break? Is it
Yeah.
about break?
Only this front page, okay? Everything must be written out in expanded form, right? Don't skip on the work, but this is due on Monday. Why it's due on Monday is because tomorrow's a retake day. Therefore, any practice work that you have to work on, that's a priority. Khan Academy, don't want to sneak up on you, that's a priority. But this page, just the front page, first page, is due on Monday. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Yes,
Oh,
no.
no. Oh, congratulations.
For what?
Oh, for being a good teacher.
Landon.
Congratulations on your first meeting.
All right, that's that, man.
Don't forget to like and subscribe.